Section 7.5, we're going to go over the sum and difference formulas. This section is going to give us 6 new identities, if you will. Now, these 6 identities are extremely important. I think they're, I call them the keys to the kingdom, okay? The keys to the trig kingdom, because a lot of advanced formulas are taken from these sum and difference formulas, right? So we're going to have the sum and difference for sine, the sum and difference for cosine, and the sum and difference for tangent, so a total of 6. So the first formula, okay, if we want to do sine of x plus y, so this is angle x plus angle y. So say for some instance we don't want to add x and y together, okay? We can use angle x separate from angle y. Now, we can't just distribute sine. It's not going to work that way, all right? We need to use the formula. So the sine of a sum, I say it's sine cos plus cosine. That's what I say. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. So when I say first and second, I'm talking first is the first angle, x, and second is the second angle, y. So notice each of my terms, I always put first angle and then the second angle. So sine cos plus cosine, all right? So if we do the sum formula or the difference formula for sine, it's going to be the same except for we're going to have a minus sign in between our two terms. So we're going to have sine cos, sine of the first, cosine of the second, minus cosine of the first, sine of the second, right? Cosine, we have a sum and difference formula for cosine, right? So in those cases when we don't really want to add x and y together, right? We want to evaluate these trig functions separate from each other. The sum formula for cosine, I say is cos minus sine, right? And so I'm always going to do the first angle first and the second angle second. So cos, cosine of the first, cosine of the second, minus sine of the first, sine of the second, right? Always x then y here, right? So cosine of a difference is going to have the same terms, but we're going to put a plus sign in between them. So it's going to be cos plus sine, right? Cosine of the first, cosine of the second, plus sine of the first, sine of the second. So just comparing these, I like to have kind of some devices to help me remember. So the difference here is sine mixes sine and cosine together in a term. Cosine keeps the same sine functions in a term, right? Now sine, while the terms are mixed together in the same term, the sign of a sum is a sum, right? And the sign of a difference is a difference. The SIGN is the same here, okay? Now, on cosine, when the terms have the same trig function, the sign in between is opposite, right? So we have the sum for a cosine is minus, and the difference for a cosine is plus. And that helps me out a lot, okay? The terms are mixed, the signs are the same, the terms are the same, and the signs are opposite. All right, so we have 2 more. We have tangent sum, right? The most important thing to remember about tangent is that it's a fraction, right? We're going to get tan x plus tan y over 1 minus tan x tan y, right? So the identity is a fraction. The numerator, right, it does appear that you can just distribute the tan, okay? But that's really a false assumption there, right? Because the tangent is a fraction here. But that might help you remember this identity, right? So the top is just tan x plus tan y, all right? And then you have to remember the denominator, okay? Now, tan of a difference is going to do the same thing. We're going to get tan x minus tan y, but that's just the numerator. The denominator, we're going to get 1 plus tan x tan y. Right? So there's our 6 new formulas, okay, our new identities. But these really are the keys to the kingdom, guys. You really do want to make sure you know how to use and have these memorized, right? They're going to come in really helpful. All right, so I have 11 examples of how to use the sum and difference formulas. All right, example number 1. Sine of 195 degrees. Right? 195 degrees is not a point we know on the unit circle. Right? Because 195 degrees is 15 degrees past 180, right? It's just kind of in quadrant 3, if you will, right? 15 degrees. So we don't have points on the unit circle. Sorry, that's really super tiny. We don't have points on the unit circle for 15 degrees. But could we write 195 degrees as a sum or difference of angles that we do know, right? So what about 150 plus 45? 150, we know that point on the unit circle. 45, we definitely know that point on the unit circle. So I could write this as a sum, right? I could also write this as a difference. What about 225 minus 30? Right? So 225 is the 45-degree angle here in the third quadrant. 30, right, is that nice point here. I think I'm going to do 225 minus 30, right? I'm going to write 195 degrees as a difference between 225 and 30, right? So now what I can do is I can use the difference formula for sine. And I'm able to use those two values on the unit circle for 225 and 30, right? So the difference formula for sine, let me bring it back down, okay? We have sine cos minus cosine. So sine of the first, cosine of the second, minus sine cos minus cosine. Cosine of the first, sine of the second, right? And these are 4 individual points on the unit circle, okay, that we need to evaluate. So to do that, I'm going to go ahead and for 225 degrees, I'm going to draw a little unit circle here to look at. Right, 225 is down here in quadrant 3. The point on the unit circle, negative 1 over rad 2, comma, negative 1 over rad 2. Right, for 30 degrees is in the first quadrant, and the point for 30 is rad 3 over 2, comma, 1/2, right? And I just remember that by, I know sine of 30 is 1/2, right? And I know the sine is the y value. So I just memorized that one, okay? All right, so here, sine of 225 is the y value at 225 degrees. So we're going to get negative 1 over rad 2. Then times, right, cosine of 30. Cosine of 30 is the x-coordinate here for the 30-degree one. Right, and the x-coordinate is rad 3 over 2. Right, minus cosine of 225 is the x-coordinate here, negative 1 over rad 2. Okay, sine of 30 is the y-coordinate here, which is 1/2. Right, so I just took all 4 of these and stated what their point was on the unit circle. So I have negative rad 3 over 2 rad 2, basically plus 1 over 2 rad 2, okay? And so I have a common denominator, so I'm just going to write this negative rad 3 plus 1 over 2 rad 2. Now, if you're not using 1 over rad 2, and instead you're using rad 2 over 2, your answer would be equivalent. Whatever you got, you could plug it into the calculator and get a decimal. Okay? If you plug this fraction into the calculator, you'll get the same exact decimal. As a point, if you plugged in sine of 195 degrees, you would get the same decimal as those two fractions. Right? Now, the computer is not going to accept your decimal answer, right? You got to be able to write the exact form, which is this one, okay? And your calculator will not change that decimal to this fraction, okay? It doesn't use those irrational, it doesn't know those irrational values here, okay? So the only way to get the exact answer is to split this up, evaluate all four of those functions, and then simplify your answer. Okay, let's try another one, but in radians. So let's do cosine of pi over 12. All right, so cosine of pi over 12. We have pi over 6, we have pi over 4, we have pi over 3. We do not have pi over 12, right? So what I would do is, honestly, I'd probably change this to degrees, okay? So if I did 180 over 12, because pi is just 180, I forgot my calculator today, so I'm just going to work this out. And I'm going to get 15, okay? So pi over 12 is equal to 15 degrees, right? So how do we get 15 degrees? Obviously, we're going to have to do a difference, right? 60 and 45 is 15 degrees. 45 and 30 is a difference of 15. You could go 150 and 135 if you wanted to, but I would keep it in quadrant 1, right? So if this is 15 degrees, I'm going to write this as a difference. Let's go ahead and do 60 and 45. Okay. So if you wanted to change this to radians now, you could, because 60 is just pi over 3 and 45 is pi over 4. So this is really the same thing as cosine of pi over 3 minus pi over 4, right? And how would we confirm this, right? It's pi over 12. You need to get a common denominator. Multiply this one by 4, multiply this one by 3. 4 pi minus 3 pi over 12 is indeed pi over 12, all right? But I think converting it to degrees makes the most sense, right? So I'm going to go ahead and continue working this in degrees, right? Because the answer is the fraction that doesn't have to deal with radians or degrees. Now, we need to use the difference formula for cosine. So get your paper handy, right? The difference formula for cosine. Cos, cos, plus sine, sine. So cosine of the first, cosine of the second, plus sine of the first, sine of the second, right? And so these are four values. Cosine of 60 is what? Cosine of 60 is the x-coordinate at 60 degrees, right? Cosine of 45 is what? It's the x-coordinate at 45 degrees, right? So, and then we're going to do the same for sine. Sine is the y-coordinate at 60 degrees and the y-coordinate at 45 degrees. So I'm going to draw a little point on the unit circle, right? This is 60 here. So the point for 60 degrees, 1/2 rad 3 over 2, right? And then we also need the point on the unit circle for 45 degrees, which is 1 over rad 2, 1 over rad 2, right? That's my preferred form, right? So now we need to evaluate these four, okay, multiply and add them together. So we're going to get the x-coordinate at 60 times the x-coordinate at 45 plus the y-coordinate at 60 times the y-coordinate at 45. Right? So now we have 1 over 2 rad 2 plus rad 3 over 2 rad 2. So I'm going to get 1 plus rad 3 over 2 rad 2. Right? This is the exact solution for cosine pi over 12. Right? So if you were to type cosine pi over 12 into your calculator, the decimal would be exactly the same here. All right, so the next, actually 3, instead of giving you cosine of an angle, I'm going to give you what the sum and difference formula says, and you're going to work backwards. Right? So number 3, what's cosine 40, cosine 10, plus sine 40, sine 10? Right? You need to match this to the correct identity, right? So the tells here are, we have cos, cos, and a sine, sine. So the terms have the same trig function. Well, which function did that? Which function had the same? A cosine, right? Now, the cosines, one had a minus in between and one had a plus. So which one had the plus, right? The one that had the plus was the subtraction one. So according to this formula, if I just work backwards with it, this is a cosine of the first angle minus the second angle. Right? And 40 minus 10 is just 30. So it is nice to be able to identify that as just cosine of 30, because cosine of 30 is a point we have on the unit circle, and cosine of 30 is rad 3 over 2. Okay? So if you were to type all this in, you get a decimal, and that decimal is going to match what you get for rad 3 over 2. Right, so we're just working backwards. We're matching this sum formula or difference formula to where it came from. All right, number 4, tan 40 minus tan 10 over 1 plus tan 40 tan 10. Right, so obviously this is a tangent formula, right? 40 is the first, 10 is the second, and so is this the difference formula or is it the sum formula? So if you remember, right, or you're looking back, the minus sign on top matched the difference formula for tangent. So this is the same thing as tangent of 40 minus 10, because it's a difference formula for tangent, which is tan of 30 degrees, right? Now, to evaluate tan of 30, I think I'm just going to use a special triangle here. Here's 30, here's 60. The sides opposite, the 30 is always a 1, the hypotenuse is always a 2, and the side opposite, the 60, is rad 3, right? So what's tangent of 30? Opposite over adjacent gives me 1 over rad 3, right? So if points on the unit circle is not something you have memorized, those special triangles will always work as well. Okay. All right, number 5, sine pi over 18 cosine 5 pi over 18 plus cosine pi over 18 sine 5 pi over 18. All right, so you can kind of see the pattern, right? Pi over 18 is the first angle, 5 pi over 18 is the second angle. And our terms, we're mixing sines and cosines together. We have a sine cos plus a cosine. So if you look through your formulas, which one does sine cos plus cosine? That's the sine of a sum, right? So I'm actually not going to change these to degrees here, because if I wanted to add the first angle and the second angle, that's pretty easy to do, right? Pi over 18 plus 5 pi over 18 is 6 pi over 18. So I'm just going to keep it, right? So this is the sine of the first angle plus the second angle, right? And so pi over 18 plus 5 pi over 18 is 6 pi over 18. And 6 pi over 18 reduces to pi over 3, right? Pi over 3 is 60 degrees, right? What's sine of 60? Right, I think it's rad 3 over 2. But we have a special triangle right here. Here's our 60 degree. opposite to 60 over hypotenuse is indeed rad 3 over 2. Right? So we do have some examples of when we're going to go backwards with the sum and difference formulas. All right, the next type are, quite honestly, my favorite. Right? These are what we call what are they called? There's some identities that people have you memorize. I guess I've just proven them so long I don't even remember what they're called. Wish I could remember. Oh well. So sine of pi over 2 plus theta equals cosine theta. This is kind of like an identity, okay, that we want to verify. We want to verify this identity. And when we go to verify an identity, remember we want to work on just one side, okay? So you can pick the left-hand side or you can pick the right-hand side, but I would always pick the left-hand side here. All right, so I'm going to pick the left-hand side. I'm going to work with the left-hand side only. And I'm going to make the left-hand side equal to the right-hand side. Right? So we have sine of angle pi over 2 plus angle theta. So this is a sum, right, inside a sine function. So I'm going to use the formula for the sum of a sine, which tells me I need to do sine cos plus cosine. Right? So this identity, sine of the first times cosine of the second plus cosine of the first, sine of the second. Right? Now, unlike the other ones, this expression here really only has two trig values that we can evaluate because we don't know what theta is, right? Theta is a variable. But we know exactly where pi over 2 is, and we know what sine and cosine of pi over 2 is, right? So we're going to evaluate these two, right? And these two only. We're going to leave cosine theta and sine theta alone. So if I were to kind of draw, again, a unit circle, pi over 2 is at 90 degrees, and the point on the unit circle for 90 degrees is 0, 1. Right? The cosine is going to be the x-coordinate, the sine is going to be the y-coordinate. So sine of pi over 2 is the y-coordinate, which is 1. So that one, sine of pi over 2 is 1, and we replace it. That still gets multiplied times cosine. Plus cosine of pi over 2. If I were to evaluate this, that's the x-coordinate there, which is 0, and that still needs to be multiplied times sine theta. So 1 times cos plus 0 times sine, this is going to go away, and we get cosine theta, which is exactly what we wanted to verify that it equaled. Okay, so I really do enjoy these a lot, using these sum and difference formulas to verify these identities here. So let's do another one. Number 7, cosine of pi plus theta equals negative cosine theta. Right? So if you're a quick learner, you might pause, see if you can get this one right. Right? I am going to pick the left-hand side again because I can use the sum formula for cosine. Right? So the sum formula for cosine, cos minus sine, sine. So I'm going to do cos minus sine, sine. Now I need to evaluate cosine pi and sine of pi. So what is the cosine of sine of pi? I'm going to go to the unit circle and find its point. Right? So pi is here at 180 degrees. The point on the unit circle is negative 1, 0. So the cosine is the x, the sine is the y. So this is equal to negative 1 times cosine minus 0 times sine. So I'm going to get negative cosine theta equals, indeed, the right-hand side, right? We wanted it to equal negative cosine, so we got it done. All right, number 8. tan 2 theta, or 2 pi minus theta equals negative 10. Are they cofunction identities? They might be cofunction identities, but don't quote me on that. All right, again, I need to verify that this is true. I'm going to start with the left-hand side because I have a difference formula for tangent that I can use. All right, so the difference formula for tangent is tan of the first minus tan of the second. Tan of the first minus tan of the second, all over 1 plus tan of the first, tan of the second. Okay. So we need to know what tangent of 2 pi is. All right, so I'm going to go on the unit circle, find 2 pi. The point on the unit circle is 1, 0. Right, and tangent is the y value over the x value, because tangent is sine over cosine. So tan of 2 pi is 0 over 1, which is just 0. Right? So if I evaluate these two and make them 0, I'm going to get 0 minus tan theta over 1 plus 0 times tan theta. So I'm going to get negative tan theta over 1, which is indeed equal to the right-hand side, right? Negative tan theta. We got it done. Okay, we started with the left-hand side, worked on the left-hand side only, and made it equal to the right-hand side, right? I really do enjoy these. You can probably expect to see a couple of these on your test, right? All right, so the next couple are just as fun, y'all, all right? I really like these next couple too. I really like sum and difference formulas. All right, this is where it's at here. All right, number 9, cosine of tan inverse of 4/3 plus cosine inverse 12/13. Right. This is where it's at. All right, we got these inverse trig functions inside a sum formula for cosine. Now, to help simplify this, okay, remember that the answer to an inverse function is the angle, right? So this is I'm going to let this be some angle x. And even though I don't know the value for this angle x, I can draw the triangle for angle x, right? So what I'm going to do is I'm going to go ahead and draw the triangle, right? Tan inverse of a positive ratio means that that triangle should be drawn in quadrant 1. I'm going to call that little reference angle there x, right? So tangent is opposite over adjacent, so the opposite side is 4. The adjacent side is 3, so we got a 3, 4, 5 going on here, right? Here's my triangle for x. This is really important, right? Now I'm going to do another triangle for the cosine inverse. This ratio is positive, so I'm going to draw the triangle in quadrant 1 as well. Now this is a different angle because it's a different triangle, so I'm going to let this be y. Okay. The answer here is some angle y, right? So I'm going to go ahead and continue drawing the triangle though. This is the adjacent over the hypotenuse. So the adjacent side is 12, the hypotenuse is 13. Okay, this is another Pythagorean triple, so the opposite side is going to be 5. If you don't trust me, you can solve it yourself. Right, 25 plus 144 is 169, and the square root of 169 is 13, all right, just to verify it. All right, so I kind of drew the triangles for inverse trig functions because that's what I want you to be able to do, all right? This answer is just x, and this answer is just y. So watch this. We now can write this problem as cosine of x plus y. Some angle x plus some angle y. And even though I don't know the exact value here, I can still evaluate them if I use the triangles. Right? So first I'm going to use the sum formula for cosine. The sum formula for cosine, cos minus sine. Right? So cos minus sine. Right? So we need cosine of angle x times cosine of angle y minus sine of angle x times sine of angle y. So these, again, are 4 different values. I need to evaluate that. But I can just use the triangles that I've drawn up here. Right? So what's cosine of x? Find the x triangle. Adjacent over hypotenuse gets us 3/5. Right? What's cosine of y? Go to the y triangle. Adjacent over hypotenuse is 12 over 13. Right? What's sine of x? X triangle, opposite over hypotenuse is 4/5. Sine of y, opposite over hypotenuse is 5/13. Right? So to simplify this, I'm going to get 36 over 65 minus 20 over 65 is 16 over 65. Right? So the exact answer is 16 over 65. Right? Not so bad, right? Not so bad. So let's do a couple more, right? 2 more, just like this. Let's do sine of sine inverse of 1/2 plus cosine inverse of 0. All right, so the answer to that inverse trig function is some angle x and some angle y. Right? This time we are going to know what the angles are, but we can draw a triangle. So I'm going to let this be angle x. Right? Let's draw a triangle for angle x. Right? The ratio is positive, so I'm going to draw in quadrant 1. Here's my little angle x, opposite over hypotenuse. So this looks like a special triangle, right? If we have 1, 2, the last side is rad 3, and so we know angle x to be 30 degrees. We know that, okay? Let me just write that since we know it, okay? On the previous example, we didn't have an angle we knew. Okay, now this is, I'm going to let be angle y, right? But angle y, we can't draw a triangle for that, right? So what we have to ask ourselves is, where is cosine 0? Where? Okay. Where is the x value 0? Right, so x is 0 here, and x is 0 here. Right, we're going to get 0, 1 here, and 0, -1 here. But remember, the answer to cosine inverse is between 0 and pi, so we are going to pick pi over 2 here. Right, so this angle y is pi over 2, or I guess I could write it in degrees, 90 degrees, right? Now, I could just change this to 30 and this to 90 and then add them together and do the sign there, but I'm going to use the formula because I love the formula, all right? So this is sine of angle x plus angle y, right? Even though we know x is 30, and y is 90. I'm going to keep them as x's and y's, right? So I'm going to use the sum formula for sine. Sine cos plus cosine. Sine cos plus cos sine. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Right? And then I'm just going to use my triangles here to evaluate all 4 of those values. Sine of x, 1/2. Cosine of y, 0. Cosine of x, rad 3 over 2. Sine of y, 1. Right? So then we're going to get, as an answer, rad 3 over 2. Okay? Which would have been the same thing, right? Sine of 30 plus 90 is sine of 120. And if you go look on your unit circle, oh, my bad. If you go look on your unit circle, sine of 120 should be rad 3 over 2. All right, one more. We could do it. number 11. Let's do sine inverse 4/5 minus tan inverse 3/4. This would have probably been a you try it on your own example if you were here in class. Alright, so if you want to pause the video and try it on your own, please feel free, because at this point I really think you should be able to evaluate these. Alright, so I'm going to let this be angle x. I'm going to let this be angle y. I'm going to draw the triangle for x and y. So here's my angle x. Sine is opposite over hypotenuse, so the last remaining side is 3 here. Here's angle y. Opposite over adjacent, so hypotenuse is 5. So both of them are 3, 4, 5 triangles, but I think x, y is up in here, but I like having the 2 different triangles. All right, so I've simplified this to sine of angle x minus angle y. So I'm going to use the difference formula for sine. Sine cos minus cosine. Sine cos minus cos sine. Right? Remember, always put the x first and the y second. Alright, so then I'm going to evaluate for all 4 of these. Sine of x, opposite over hypotenuse. Cosine of y, adjacent over hypotenuse. Cosine of x, adjacent over hypotenuse. Sine of y, opposite over hypotenuse. So I'm going to get 16/25 minus 9/25 for a final answer of 7/25. Right? So there's the sample types of equations that you can use with sum and difference formulas. Make sure you're working on memorizing those and applying them to all these different situations. All right, good luck, guys.